Hi everyone. Today we're going to learn about solving one-step equations, and I'm hoping this is really just complete review for you because I'm pretty sure you learned how to solve equations last year. But it never hurts to refresh it, and we're going to kind of take it one step farther. So now we're going to actually assign a name of a property to how we solve equations. And I don't know if Mr. Curvin or whoever you might have had last year talked about this at all or not, so this part might be a tad bit newer. But basically what this is saying is that if you add a number to the left side of an equation and you add the same number to the right side of the equation, then you've produced an equivalent equation to the original one. Okay, and I think most of us know that, that's common sense, but there's actually a name for it, and it's called the addition property of equality. And then there's also a subtraction property of equality, that if I subtract the same number on both sides of the equation, then I produce an equivalent equation. So just like when we produce equivalent fractions by multiplying the numerator and denominator both by the same number, we're transforming it, but it's still equivalent. This is the same concept here. So we have the addition property of equality and the subtraction property of equality. So today we're going to look just at one-step equations, pretty basic, and how we solve them using addition and subtraction. So in this example here, we start with m minus 32 equals 18. Well, remember, our goal in solving an equation is to find out what just m is. So we're trying to isolate that variable. So to get rid of a minus 32, we're going to do the inverse operation. We're going to add 32 on both sides. So now on the left-hand side, minus 32 plus 32 cancels out and becomes 0. And so we have isolated m successfully. And on the right-hand side, 18 plus 32 gives us 50. So m is 50. Okay. And then in example 2, we had 22 plus p. Well, again, to isolate p, we need to get rid of this positive 22. Well, in order to do that, we're going to subtract 22 on both sides, and we get p equals negative 34. So I think that should be review for you. What I want to talk about right now is how do you show your work in my class for me, because that might differ from teacher to teacher. And I'm going to show you two methods that you can show your work in solving equations. The first one here, if I can get my pen to work, maybe, here we go, is going to be a horizontal method. And I believe this might be the way Mr. Curvin teaches you how to do it. So if we have this equation, we would start by rewriting the left-hand side, and then I would be adding 3 on both sides. Okay, so I add 3 on both sides, and I'm doing it horizontally. Well, negative 3 plus 3 is 0, so I have h. Negative 2 plus 3 is 1, so h equals 1. That's my solution. Now, in my class, I expect to see a check step. By a check step, I mean we're taking our solution and substituting it in for h in the original equation. So I would do a check step like this. I would say 1 minus 3, and I'm asking, does that equal negative 2? And at this point, this is where you actually have to do the math. You can't just say, yes, it checks. So I would either mentally or with my calculator make sure that 1 minus 3 is negative 2, and therefore it does check, and it works. But you have to actually physically check it. You can't just write the check step. Okay? So anytime we have an equation to solve, you should be able to check it and know whether you are correct or not before you ever turn in your paper. Now, to give you an example of what I would call the vertical method of showing your work, I don't know what's wrong with my pen today. It's not working very well. Here's how I do my work. Okay, so if I have this equation, m minus 8 equals negative 12, underneath it, I would just say I'm going to add 8 to this side, and I'm going to add 8 to this side. Minus 8 plus 8 cancels out to be 0, so I've isolated m. And then negative 12 plus 8 gives me negative 4. Let me rewrite that since my pen is all strange today. m equals negative 4. Then I do my check step, so I would do negative 4 minus 8, and I want to know, does that equal negative 12? And I do the math. Negative 4 minus 8 is negative 12, so it equals on both sides, and it works. Okay, so that's the kind of work that I expect to see when you solve an equation. Even if it's something you could do in your head, I expect to see your work. You can box in or circle in your solutions so they're easy to find, but I have no preference whether you choose to do horizontal method or vertical method. Whatever you're more comfortable with is fine with me. Okay, so take a minute and pause the video and try these on your own, and we'll check those answers first thing tomorrow in class. When you unpause, go ahead and flip to the next page, and we'll talk about multiplication and division. Okay, so the same thing really applies with multiplication and division. If you multiply both sides by the same number, you've created an equivalent equation. And if you divide both sides by the same number, you've created an equivalent equation. So let's look at some examples here. If we have 3.5p equals 1.5, first we can convert 3.5 to a mixed number or an improper fraction, 7/2. Then I can do a couple different things here. What they chose to do in this example is they're using the multiplicative inverse property. So they're multiplying 7/2 by 2/7 so that those cancel and become 1. And that helps me isolate p to 1p. So then I would also multiply the right-hand side by 2/7, and then I get 2 times 3 is 6, 7 times 2 is 14, so that actually gives me 6/14, which reduces back down to 3/7. So I get p equals 3/7. Now, in theory, you could also use the division property of equality here as well. So I could have just divided by 3.5 on both sides and used my calculator to do that. So that's also an option, but they really wanted to stress that you can use multiplicative inverses here, and so that's why they did it that way. But it would give you the same result no matter what. Then over here, we have negative 5n equals 60. To isolate n, I need to undo this multiplication. So I'm going to divide both sides by negative 5. Well, here, negative 5 divided by negative 5 gives me 1n, and 60 divided by negative 5 is negative 12. Okay, so basically the same thing, just using addition or using multiplication and division. So take a few minutes and try these practice ones down here below, and we will check those answers when you get to class tomorrow. But focus tonight on making sure you're showing your work correctly and doing your check step correctly. And have a great night. I'll see you tomorrow.